EDM 60204 Measurement and Geometry, Week 12 Tessellation. Learning objectives. At the end of this lesson, you should be able to identify what is tessellation, identify how to name tessellation patterns, and draw tessellation patterns from given information. This is an example of a tessellation. Victorian floor tiles assembled by hand as bespoke, ready to fit sheets. So you can see there's a pattern there, and you can see here how this men install the patterns. So we can see a square here, then we can see another square, another square, another square, another square. Then we can see triangles, 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 triangles. So mostly are triangles inside here. Okay, this is also a triangle. This is also a triangle, triangle. This is a square, triangle, 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 triangle. So most of the shapes here are made of squares and triangles. Right, so on the left here, these are also tessellations, where you can see it's also made up of squares and also triangles. And then the other one is here, and you can see that it's made up of squares and triangles as well. Now this is another tessellation where you can see that it's made up of octagons, where it's 8. You can see from this one, 1, 2, 3. Is it 1, 2, 3, 4, 5, 6, 7, 8? Yes. Okay, so it's octagon. It's made up of octagon shapes, square, triangles as well. So all these regular shapes, once you put them together, they form patterns, beautiful patterns. And here's another one. As you can see, this is also an octagon here. And then you have the square, you have the triangles. So when you put regular polygons, they will form shapes such as these, and they will form beautiful shapes. These are what we call as tessellations. Okay, so what is tessellation? It is a pattern of shapes that fit perfectly together. There will be no spaces. So a tessellation or tiling is when we cover a surface with a pattern of flat shapes that are so that there are no overlaps or gaps. So we put all rectangles together. We can put all octagons, okay, and squares together. And then we can have different pentagons, different pentagon shapes, and put them together. Remember, no gaps in between. These are all combination of 2D shapes. Okay, there are 3 types of tessellations. One is regular, the other one is semi-regular, and the third one is non-regular. So let's have a look at each one of them. Let's start with regular tessellation. Now when we say regular tessellation, we mean to say we are using regular polygons. And you have to remember, when we say regular polygons, it means all sides have equal length. All sides have equal length. Okay, so here are the rules before we start of regular tessellation. Number one, the tessellation must cover a plane with no gaps or overlaps. Number two, the tiles must be copies of one regular polygon. And number three, each vertex must join another vertex. So that is the regular tessellation rules. So let's have a look at this. A regular tessellation is a pattern made by repeating regular polygons. So we have learned regular polygons such as equilateral, triangle, we have square, and then we have pentagon, we have hexagon, and we have heptagon, and so on. So here we can see that this all uses triangles, this all uses squares, and this all uses hexagons. Okay, so you just need to put all those together. Now the most common ones will be triangles, squares, and hexagons, because pentagons, if you want to put them together, there will be distorted type of pentagons that will go in, so it's not really a regular tessellation, so we can't use pentagon. Okay, so when we want to define regular polygons, it's where all sides have equal length. Okay, let's have a look at this regular tessellations. These are all squares put together side by side, and no gaps. These are all triangles, and these are all hexagon. Okay, so all four sides have equal length and equal angles for squares. Triangles, all three sides have equal length and equal angles, and for hexagons, all six sides have equal length and equal angles. So let's have a look at the regular polygon once again. So tessellation must cover a plane with no gaps or overlaps. The tiles must be copies of one regular polygon. So if it's a square, the next one is a square, the next one is a square, up and down, they are squares as well. Each vertex must join another vertex. Okay, so this is a demonstration. Okay, so is this a tessellation? Yes, it is. But is it a regular tessellation? No, it's not. What about the second one? Is it a tessellation? Yes, it is a tessellation. Is it a regular tessellation? Yes, it is a regular tessellation. So this one is correct. This one is not. So we look at the vertex there, because the vertex must join the other vertex. How many squares can make a complete rotation? That means 360 degrees. 4 squares. Okay, and squares can be used to form regular tessellation, like this one. Okay, so we have the right angles, and let's look at pentagon. Okay, this is thinking point 1. Can pentagons form a regular tessellation? Discuss in your group and write your justification in the comment box. Remember, pentagon is a regular polygon. Okay, you just need to think about this and come up with a justification. Why is it that pentagon can or cannot form a regular tessellation? Thinking point 2. Can hexagons form a regular tessellation? Okay, so you can discuss with your group, or you can start thinking on your own, and then write whether hexagon will form a regular tessellation. You need to justify. Now this is heptagon. Heptagon means 7 sides. Can heptagons form a regular tessellation? Okay, so you also need to think about this. Even though heptagon is a regular polygon. Okay, can heptagons form a regular tessellation? The answer is no. Heptagons cannot form a regular tessellation because they overlap with each other. Okay, conclusion, even though pentagons, heptagons, and octagons are regular polygons, only hexagons can form regular tessellation without overlapping and with no gaps. You see, there's an overlap here. So you can't use heptagon to form a regular tessellation. Alright, so the only regular polygons that tessellate the plane are triangles, squares, and hexagons. So let's look at the first one over here, which is the regular triangle or equilateral triangle. So you can put them together like this. Okay, and the base tile or the name is 3.3.3.3.3.3. Okay, we will look at how to name a tessellation pattern later. So when you put them side by side, it becomes a tiling, and you can see how it fits into each other's vertex. Okay, nicely, no gaps. Let's look at regular equilateral. That means it's a square. So when you put them together, they becomes like this. It's a 4.4.4.4, and then you take all that and becomes a tiling, so there will be no gaps either and no overlaps. Okay, this is a regular hexagon, and when you put them together, you will see there are also no gaps and no overlaps. So when you put all of them together, it becomes such a lovely pattern like this one. So all 3 of them will have no gaps and no overlaps. Okay, no gaps, no overlaps. And that makes them regular tessellation. Right, let's look at the second type of tessellation, which is semi-regular or semi-regular tessellation. Here are some rules for semi-regular tessellation. Number 1, the tessellation must cover a plane with no gaps or overlaps also. Okay, the tiles can be made from more than one regular polygon to form a semi-regular tessellation. Each vertex must join another vertex. Okay, so there are 8 semi-regular tessellations. So that means you're not going to use just one type, like for example triangles, but you're going to use more than one type of 2D shapes, okay, to form this semi-regular tessellation. So it could be a triangle and a square. Okay, so let's see the 8 semi-regular tessellation. Okay, this is an example of a semi-regular tessellation made from a square, a hexagon, and a dodecahedron. That means 12 sides. So this is the 12 sides. Okay, and then you have the hexagon, and then you have the square. So when you put all this together, it forms this pattern, which is lovely. Okay, that's number one. That's the square, that's the hexagon, and that's the dodecahedron. And that's the vertex. So always make sure that the vertex of all the 2D shapes will touch each other. Here is another example of a semi-regular tessellation, and this is the second type. Okay, so here you can see that we have 3 triangles and 2 squares. So the triangles are here, 1, 2, 3, and then we have the squares 1 and 2. And you can see that the vertex here, they all touch each other. So then the pattern becomes this lovely pattern here. That's the tessellation. Next, number 3 is where you have 4 triangles and a hexagon. So you have 4 triangles, 1, 2, 3, 4, and a hexagon. Okay, so we have the vertices all touching each other, and you can have this kind of pattern as well, where you have more triangles attached to the original triangles there. So you will have this kind of pattern here. Very nice. That's the tessellation. Okay, the fourth one is made of 3 triangles and 2 squares. So we have 3 triangles, 1, 2, 3, and 2 squares, 1, 2. So the vertex all touch each other here. And then you can add another piece here. So you will have this kind of pattern. Tessellation pattern. And the 5th one is where we have 3 triangles and 2 squares. So it looks like the original one that we saw earlier, but the only difference is that you can add another piece of a triangle at the bottom. Okay, so then it becomes this pattern. The vertex is here. The number 6 is a triangle made up of a triangle, 2 squares, and a hexagon. So we have a triangle. This is the triangle here, 2 squares, and a hexagon. And then you can add one more triangle over here and a square, and then you can see it here. Okay, this is a triangle, then this is the square, and this is the hexagon. Okay, and then you have this triangle and another one, a square. So when you put them all together, you will have this kind of pattern, tessellation pattern. Number 7 is made up of 2 triangles and 2 hexagons. So the triangles are up and down, the hexagons are on the left and the right, and the vertices all meet at the same point. And then you can add 2 more over here, 2 more triangles up and down, and you have this pattern. Nice. And number 8 is where you have 2 octagons, 8 sides, and a square. So you have 2 octagons left and right, and a square here. The vertices are all here, and then you can add another piece of a square. Then you will get this kind of tessellation pattern. Okay, so those are semi-regular tessellation patterns where they are made up of more than one regular polygon. They are made up of several regular polygons. Number 3 is non-regular tessellation. So we call this demi-regular tessellation. We have one uniform tessellation, which means they are regular tessellation and semi-regular tessellation. So if the arrangement at each vertex in a tessellation of regular polygon is not the same, then the tessellation is called demi-regular tessellation. And then we have a 2 uniform tessellation, which means there are 2 different vertices. Example in a demi-regular tessellation as well. 3 regular tessellation, there are 3 different vertices. Example again in demi-regular tessellation. Okay, so these are non-regular tessellation. There are also demi-regular tessellations, but mathematicians disagree on what they actually are. And some people allow curved shapes, not just polygons. So we have tessellations that looks like this. Curvy shapes, circles, eagles. Okay, you can try tessellation artists. You can click on the link here if the link still works. And then you can create your own tessellation. Okay. Naming tessellation only works for regular and semi-regular tessellation, not the non-regular tessellation. Okay, so let's look at an example here. These are all made from hexagons. We have to look at the vertex. Okay, we have to look at the vertex. So a vertex is just a corner point. What shapes meet here? So we determine that the vertex is here. Okay, and then let's see what are the shapes that's connected to that vertex. On this side, you see that there are 3 hexagons that meet at this vertex, and each hexagon has 6 sides. So we name it as 6.6.6 tessellation. For a regular tessellation, the pattern is identical at each vertex. Let's look at semi-regular tessellations. Here are some semi-regular tessellations. They are made of 2 or 3 2D shapes or regular polygons. The first one, we need to look at the vertex. So here you can see that will begin with the smallest number of sides at the vertex. We have to determine where the vertex is. Okay, you can go clockwise or counterclockwise. Okay, clockwise or anti-clockwise. So either way, you start from the smallest number. So it will be 3.6.3.6, because you can see that we are going, let's see, from this side, 3.6.3.6. Okay, so that's how we got 3.6.3.6, and the vertex is over here. So you can have a look at each vertex. Okay, you can have a look at each vertex. You will see that it is 3.6.3.6. Okay. Next, okay, let's have a look at this one though. You can take 6 and then 4, 3, 4. Okay, we are looking at the vertex over here, if you can see that one. So here we can see that we need to start from the smallest number of the sides. So the smallest number will be the triangle, which has 3 sides. So because the vertex is over here. Okay, all right, so you can start from clockwise or anti-clockwise from the smallest number. So the smallest number is 3, then you can start 3.4.6.4. so you can have this name, 3.4.6.4. Another one. Okay, so here we will look at a vertex, and that is the vertex here. So we will take 8 and 8 and then 4. Okay, so this is the vertex that joins the three shapes. Okay, and start with the smallest number again. So it's going to be 4, 8, 4.8.8. Okay, so we have 4.8.8. All right, thinking point number 3, or is it thinking point number 4? Draw the tessellation based on the given name. Right, so the shapes are given, octagon and square, and the name is 4.8.8. Another one, 2D shapes are hexagon, triangle, and square. Okay, hexagon, triangle, and square. Okay, so the shape is, the name is 3.4.6.4. Okay, so you do have to think of what kind of a shape that would be. For this one here, okay, so 8 and 8 and then a 4. So that means there will be 2 octagons and 1 square. So 2 octagons. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. My octagon is not so nicely drawn. Okay, so if it's an octagon, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 8, 6, 7, 8. Okay, so these are octagons, and then you have one square. So it looks like that. Okay, so that's how you take a look at the name and the shapes given, and then start to draw the tessellation. Over here it is 3.4.6.4. So we can have a look at 3.4.6.4. So that is how the original tessellation shape looks like. Okay, to name a tessellation, go around a vertex and write down how many sides each polygon has. So you will need to look at the pattern, the shape, the 2D shape, how many sides each shape has. So for example, 3.12.12. And always start at the polygon with the least number of sides. So it should start with 3, followed by 12, followed by 12. Not 12.3.12. So this is wrong. This is correct. Okay. Question 1. For the tessellations above, is the pattern the same at each vertex? It could be, okay, if it's all regular tessellation. If it's semi-regular tessellation, then the pattern will be different. Number 2, one of those patterns becomes different when we make a mirror image of it. Which one? So we need to look at this one. Okay, mirror image of it. Okay, let's look at tessellation here. Okay, so we have this. We need to name it. So we need to find a vertex that is linked to all shapes. So this is one vertex. So we can see that we have these triangles and these hexagons. So they're all attached to the same vertex. Okay, so we can start from the lowest number. This has 3 sides, 6 sides, 3 sides, 6 sides. Okay, 3 and 6. So we can start from here, and we can go clockwise, or we can go anti-clockwise. It will be the same. So we have 3. So if we go this side, then we have 3.6.3 again here, dot 6. Okay, so yay, correct. Now next, all right, so let's find the vertex first. You can find it here, okay, or I'll just use green. You can see it. And we have a triangle, 2 squares, and a hexagon. Okay, and hexagon. Okay, which one has the smallest sides? It will be the triangle. So since it's the triangle, we have 3. You can go like this all the way around, or you can go like this all the way around. Okay, so we start with 3.4.6 dot 4. Okay, so that's the answer. Yes, correct. Sorry, this is the wrong one. Okay, so it should be 3.4.6.4 because we are going all around. Yes, typo. Okay, let's have a look at this one. Ooh. So let's find the vertex. Okay. So let's have a look at the middle one here. Right, because I had to redo this pattern, and that's why you see some gaps there. Not so good at that one. Okay, so this is the vertex. We have 1 triangle, 2 triangles, and 3 triangles, and then we have 2 squares. So you can start from any of the triangles, but the best one will be from where we have 2 triangles. So we have 3 dot 3 dot 4 dot 3 dot 4. 3.3.4.3.4. Okay, next, this is an octagon. Okay, this is an octagon, so we can see that the vertex is here, and we can see that we have 1 octagon, 2 octagons, and a square. So we have 8, 8, and 4. So we start from the 4. Okay, this is 4. Then we can go all the way around. Okay, clockwise or anti-clockwise or anti-clockwise. And then we can write it as, okay, 4.8.8. Okay, 4.8.8. There you go. So that's correct. Okay, so this one, we have to find the vertex, and the vertex looks like it's here. Okay, let's just find one. Okay, let's say that's the vertex. So we have 1 triangle, 2 triangles, 3 triangles. This is supposed to be a square and another square. Okay. So start from the first triangle, either this side or this side. Okay, so we have 3.3.3.4.4. Okay, there you go. 3.3.3.4.4. Okay, next, this is where we need to find the vertex. Okay, so let's find one vertex. Let's say that this is the vertex over here. You can see the green color. Okay, that's the green color. So we have 1 square, 1 4 sides, and the other one is 6 sides, and another one is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12 sides. So how do we write that? You must remember that only the shapes that is connected to this vertex, the same vertex. So we can say 4.6.12. It's going this way. Okay, so I'm following clockwise. Now if I don't follow clockwise, I go anti-clockwise, it will also no, we have to follow this numbering. Okay, so you can see here 4.6.12. So for this one, you can't go anti-clockwise because we have number 6. So we can't have 4.12.6. Okay, we can't have 4.12.6. So we need to go for smallest, second smallest, and the largest. Okay, another tessellation. Okay, this is 12-sided 2D shapes, and you can see that smack in the middle here there's a triangle. Okay, so find one vertex. So you can see that this is 12, this is 12, this is 3. So how do you write the name? Then you can write the name as, okay, go clockwise 3.12.12. For this one, if you go anti-clockwise, you will also get 3.12.12. Okay, yes. Right. This one, let's find the vertex. So you can see that this is the vertex here. It's in white. And we have 1 triangle, 2 triangles, 3 triangles, 4 triangles, and a hexagon. So we have to follow this way, no other way. So it would be 3.3.3.3.6. Okay, 3.3.3.3.6. So there are sometimes where you can have the freedom of naming it whether either clockwise or anti-clockwise, but there are instances where you can only follow either clockwise or anti-clockwise. Okay, only one. Alright, so here are other resources that you can go and have a look at tessellation. Some more tessellation. Right, so to test your whatever that you have learned, and if you wish to take the quiz, you can do so. Okay, and if you have any questions, please do write it in the comment box.